in this example, the two matrices had the same dimension. They do not have to have the same dimension. But these inner terms do have to be the same. The outer terms do not. Okay. So you could perform this matrix multiplication if this were a 3 by 2. Suppose A is a 3 by 2. And suppose B is a 2 by 4. And you want to multiply them to get the product matrix. First of all, can you multiply A times B? Yes. And what will the dimension of the resulting matrix be? It'll be a 3 by 4. Okay. One of the interesting things about matrix algebra that's different from scalar algebra is matrix algebra is not commutative. Multiplication is not commutative. Matrix multiplication is not commutative. The order in which you write the two matrices makes a difference. If you're dealing with scalar algebra, let me just make this simple. 3 times 5 is equal to 5 times 3. 2 times 4 is 4 times 2. So if you're dealing with scalars, the order in which you do the multiplication doesn't make any difference. That's not true in matrix algebra. You can see that right here. A times B is a 3 by 4, but what is B times A? Undefined. It's not even defined. You can't even multiply it. Furthermore, in this case right here, in general, I could get myself in trouble because I haven't worked it out. In general, even if it is defined, A times B is not generally equal to B times A. Let's just check it out in this example. In this example, we had A defined to be this, B defined to be that. Suppose we reverse the order. What would we get? Suppose we go back to the example of the 2 by 2s. What is B times A? Well, just substituting in, here's our B. It's a minus 1, 2, 2, 5. And A is a 1, 0, minus 3, 2. Just to practice your multiplication. Once in a million cases, they would be the same, but I don't think they will be in this one. What will be the first element of that product matrix? Can you work it out in your head? What happens when you multiply this row times this column? What do you get? You get minus 1, minus 1, minus 6, negative 7. Okay. So you can see right away they're not the same. Because here, when we multiply A times B, we've got minus 1. When we reverse the order, the first element's a minus 7. What would the next element be? Just practice your, what would it be? 4. That'd be minus 1 times 0 plus 2 times 2, or a 0, plus 4 is 4. Okay, that's not the same as the other matrix either, is it? What about the next element when you multiply second row times the first column? Yeah, you get 2 minus 15. So it'd be a negative 13. Is that what you said? Oh, and you are? Matthew. Negative 13. The final element would be what? 10. 2 times 0 plus 5 times 2. 0 plus 10 is 10. Okay. So keep this in mind. In matrix algebra, unlike scalar algebra, the order in which the matrices appear is important and will affect the result.